All right, thanks for joining me for video number 3. In this video, we're going to go from grams of one substance to grams of another substance using a stoichiometry sequence. All right, so we're going to use some of those conversion factors that we were using from the last semester, where you're using 1 mole is equal to the molar mass, or 1 mole is equal to Avogadro's number, 6.02 times 10 to the 23. And that can be atoms, molecules, or formula units depending on what we're talking about. So remember, we're going to use the term atoms if we're talking about an element. We're going to use molecules if we're talking about a covalent substance. And we're going to use formula units if we're talking about an ionic compound. Okay, so we're going to take those mole ratios that we were using in the previous 2 videos and combine them with these conversion factors that we were using from last semester. So here, we've got number 5 in our packet. How many grams of solution are produced when 25.03 grams of aqueous iron 3 sulfate are reacted with an excess of zinc metal to produce zinc sulfate and iron? So here's our balanced chemical reaction. And again, we always start by writing our given, 25.03 grams of Fe2SO4 3. So let me get my annotate tool here. So since we're starting with grams of Fe2SO4 3, we need to have grams of Fe2SO4 3 down here at the bottom. And if we're going to be using grams, that's where we get our molar mass from the periodic table. So we have to have 2 irons plus 3 sulfurs plus 12 oxygens. And that molar mass is 399.88. And we have 1 mole of Fe2SO4 3 here. Now, this is important. This is 1 mole of Fe2SO4 3 because we have the molar mass down here. Molar mass is the mass of 1 mole of that substance. It's not because this coefficient up here is a 1. That's not why it's a 1 here. Now, since we have moles of iron 3 sulfate there, we're not at our final answer yet, which is looking for grams of solution. We're looking for grams of the zinc sulfate. So we have to keep going. Since we have moles on the top, we need to have moles of iron sulfate down here at the bottom. We have to keep the same unit and the same substance down here at the bottom. This time we're going to put 1 with it because of the coefficient of the iron sulfate. Okay, this 1 is because the iron sulfate's coefficient is a 1, and we're going to use the mole ratio to switch from moles of iron sulfate to moles of zinc sulfate up here on the top. Okay, so it always has to be a coefficient over a coefficient. We're not at our final answer yet because we're looking for grams. So since we have moles up here on the top, we need to have moles down here at the bottom. We can only use the coefficient 1 time. So since we already used the coefficient, we have to have 1 down here. We're looking for grams of zinc sulfate up here on the top. So that means we're going to go back to our periodic table using the mass of 1 zinc, 1 sulfur, 4 oxygens, which is 161.45. We are going to go ahead and solve. Now you can solve these any way you would like to. If you want to multiply across the top first and then divide across the bottom. I personally always work left to right. So I take 25.03 divided by 399.88 because it's in the bottom, times 3 because it's in the top, times 161.45. And I'm going to have 4 sig figs because I've got 4 sig figs in my starting value. So my answer would be 30.32 grams of zinc sulfate. Okay. Let me just get all of this. I don't know why there's a random 1 there, but okay. So how many grams of barium chloride solution would be needed to produce 33 grams of iron 3 chloride when reacted with iron 3 sulfate? So here is my reaction. I am looking for grams of barium chloride solution. So I'm looking for grams of this. All right. I always start by writing my given. So I start with 33 grams of iron chloride. I start up my dimensional analysis. Remember, whatever unit I start with, that unit has to go at the bottom. So I have to have grams of FeCl3 down here. If I have grams, I go to my periodic table and figure out my molar mass. So the molar mass of FeCl3 is 162.2. And I know that the molar mass is equal to 1 mole of FeCl3 up here. I'm not done setting up my problem because I'm looking for grams of barium chloride. So since I have moles of FeCl3 up here, I need moles of FeCl3 down here. Now, how many moles of FeCl3 am I going to have? Well, this is where I'm going to be using that mole ratio, switching from FeCl3 to BaCl2. So I'm going to use my coefficient. So I have to have 2 moles of FeCl3 down here. I'm looking for barium chloride, so I'm going to have 3 moles of barium chloride up here on the top. I'm not done yet because I'm looking for grams. Ignore this one, don't know why it's there. So since I have moles of barium chloride on the top, I need moles of barium chloride down here at the bottom. I can only use my coefficient 1 time, so that means I'm back to using a 1 with my moles. Since I'm looking for grams of barium chloride, I'm going to go back to my periodic table, use my molar mass of each substance to find my molar mass of barium chloride, which is 208.23. Now I solve. Make sure you plug this into your calculator to make sure you're getting the same answer as me. I personally would take 33, I'm going to divide it by 162.2 because it's in the bottom, times 3 because it's in the top, divided by 2 because it's in the bottom, times 208.23 because that's in the top. I only get 2 sig figs because of 33, so that means my answer would be recorded as 64 grams of BaCl2. Okay? Hopefully that makes sense. So what I want you to do is I want you to figure out this problem. Here's a chemical reaction. Here's your problem. How many grams of copper 1 sulfide will be produced if 12.45 grams of sulfur reacts with excess copper? All right, I'm going to have you solve that problem and answer it in the Ed puzzle. And then I'm going to have you do this one and answer it in the Ed puzzle. Now with this second question, you have to remember how to predict the products of your double replacement reactions. So let me just show you that really quick since it's been a minute since we've had Christmas break. But remember, I've got iron 3 chloride reacting with potassium hydroxide. And I'm trying to figure out how many grams of precipitate. So when I do my product prediction, remember, I have my outside ions going together and I've got my inside ions going together. And I want to make sure I'm not taking the subscripts from the reactant side. I'm dropping and swapping again. So I've got KCl because K is +1 and Cl is -1. And that is aqueous because alkali metals are always aqueous. This iron has a +3 charge over here. So when it forms a product with iron hydroxide as FeOH3, and that's going to be a solid because hydroxides are usually solid. So there's your reaction for you to go ahead and balance. Just wanted to refresh on that. So give those ones a try. I'm going to be asking you for the answers in the Ed puzzle. And if you have any questions at all, just let me know about gram to gram conversions.